Welcome to the investigation, where every rock layer is a clue and every mass extinction is a planetary crime scene. You're kneeling in the shimmering heat of the Karoo Basin in South Africa. The air is dry, the sun relentless. Before you is a wall of sedimentary rock, a silent library of deep time. In the layers below your hand, the stone is rich with the ghosts of an ancient empire. You can almost feel their power radiating from the fossilized remains. Skulls the size of bear traps, armed with the first true saber teeth this planet ever produced. This was the reign of the Gorgonopsids. Ever wonder what it truly felt like to be the first detective on the scene of a 252-million-year-old apocalypse? You're about to find out.
What we find here tells a
So,
story.
before you get comfortable, take a moment to like the video and subscribe. But only if you find the investigation we're about to undertake is a valuable one. Tell us in the comments where you are watching from and which global cataclysm you want us to investigate next. Now, let's open the case file and uncover the story of a lost world. Your fingers trace the rough sandstone. Down here, in the late Permian strata, the evidence of life is abundant. You unearth the partial skull of an Sevia, a predator built like a bulldog, but armed like a saber-toothed cat. These weren't dinosaurs. They were something else entirely. Synapsids, the dominant land vertebrates of their time, and part of the great dynasty that includes our own mammalian ancestors. For millions of years, they were the undisputed rulers. The Gorgonopsid family was the apex of this dynasty, a global network of predators that stalked every corner of the supercontinent Pangea. They were fast, powerful, and ruthlessly efficient. They were, by all accounts, invincible. Then your hand reaches a line in the rock, a boundary. It's no thicker than your thumb, but it represents the greatest crime scene in Earth's history. Below it, a thriving world. Above it, nothing. The fossils just stop. The vibrant, fossil-rich sandstone gives way to a grim, dark shale, a layer of stone that whispers of suffocation and decay. This isn't a local disappearance. It's a planetary vanishing act. Geologists find this same dead zone across the globe, from South Africa to Siberia to China. It has a name, the Permian-Triassic Extinction Event. We call it the Great Dying. This is our body. Not one creature, but an entire global ecosystem. The central question of our investigation forms in the dust and the heat. What kind of force, what kind of killer, could possibly erase a dynasty as successful as the Gorgonopsids and extinguish over 90% of all species on Earth? To answer that question, you have to reconstruct the world they owned. You must walk the crime scene before the crime was ever committed. Your perspective pulls back from the rock face in the Karoo, rising higher and higher until the curve of the Earth becomes visible. Below you lies not the familiar mosaic of continents we know today, but a single, immense landmass, Pangea. It stretches nearly from pole to pole, a supercontinent so vast its interior is a world away from any ocean. This arrangement isn't just a geographical curiosity. It's the engine of the entire planetary climate. A single landmass means a single, world-girdling ocean, the Panthalassa, and one climate system operating on a scale that dwarfs anything in our modern experience. You descend into the heart of this lost world. The air is thick, and the oxygen levels are lower than you're used to, a subtle strain on every breath. The sheer size of Pangea creates a climate of brutal extremes. The coastal regions are lashed by hypermonsoons, seasons of relentless, flooding rain followed by long, bone-dry droughts. But as you move inland, you enter the true domain of the Gorgonopsids, a vast, arid expanse where the sun beats down without mercy. Think of the great deserts of today, but scaled up to cover an area the size of modern Asia and North America combined. This was a hard world. A world that bred survivors. And yet, life was everywhere. In the cooler, higher latitudes near the South Pole, dense forests of Glossopteris trees stood, their tongue-shaped leaves carpeting the ground. Herds of stocky, pig-like herbivores, called dissimians, browsed on tough vegetation, their beaked mouths perfectly adapted for shearing hardy plants. These were the grazers, the prey, the foundation of the food web. And where there is prey, there are predators. You see them now, moving with a terrifying efficiency through the sparse fern-covered plain. A pack of Gorgonopsids, wolf-sized hunters with powerful limbs tucked under their bodies, a key trait separating them from sprawling reptiles. They are not sluggish, cold-blooded lizards. They are energetic, persistent hunters. At the top of this food chain sits the magnificent Inostrancevia, a beast the size of a grizzly bear, its 6-inch saber teeth gleaming. For 10 million years, this dynasty of proto-mammals ruled Pangea. Their empire was stable, battle-tested, and successful. This wasn't a fragile ecosystem on the verge of collapse. It was a fortress. This fact sharpens the focus of our investigation. Whatever killed this world didn't just knock on the door. It blew the fortress walls to dust. A fortress world doesn't just fall. It must be poisoned from the inside out. To find the murder weapon, you return to that silent, dark layer of rock. The tombstone separating the world of the Gorgonopsids from the empty world that followed. The most powerful clues aren't in the bones anymore, but in the chemistry of the stone itself. You're moving from paleontology to planetary forensics. It's time to read the toxicology report. You carefully extract a sample from the boundary layer. Under analysis, it reveals a dramatic chemical fingerprint. The ratio of carbon isotopes, the different weights of carbon atoms, goes haywire. Life on Earth preferentially uses the lighter isotope, carbon-12. When volcanoes release vast amounts of CO2 from deep within the planet, or when methane trapped in the seabed is released, it floods the atmosphere with the same light carbon. Your sample shows a massive, sharp, negative spike, the biggest of its kind in the entire geological record. This is the smoking gun. It's a clear signature of a colossal release of carbon into the biosphere, an injection of poison on a scale that is difficult to comprehend. The planet's entire carbon cycle, the very foundation of its life support system, was thrown into chaos. Next, you examine the physical nature of the rock. That dark, finely layered shale tells its own grim story. It's black because it's full of organic material that never decayed. In a healthy ocean, tiny creatures burrow through the seabed sediment, churning it up and helping decomposition along. The perfectly preserved layers here mean only one thing. The ocean floor was completely dead. There were no burrowers. There was no oxygen. The carbon injection had triggered runaway global warming, heating the oceans to the point they could no longer hold dissolved oxygen. The deep seas became vast, stagnant, anoxic pools, suffocating nearly all marine life. This is evidence of death by asphyxiation on a global scale. The final clue comes from the few marine fossils that made it across the boundary. The shells of snails and other invertebrates are thin, pitted, and malformed. The sheer volume of carbon dioxide in the atmosphere also dissolved into the Panthalastic Ocean, turning it acidic. This corrosive water made it nearly impossible for organisms to build their calcium-carbonate shells. It was the oceanic equivalent of a chemical burn. Now, you have a clear forensic profile of the killer. The perpetrator used a weapon that simultaneously poisoned the atmosphere with carbon, suffocated the oceans, and burned marine life with acid. The question is no longer what happened, but who or what had the power to do it. With a clear forensic profile of the weapon, you can now build a list of suspects. For a crime of this magnitude, only 2 culprits have the means and the motive to kill a planet. Suspect number 1. A cataclysmic asteroid impact, a killer from the outside. Suspect number 2. A planetary-scale volcanic eruption, a betrayal from within. It's time to see which one the evidence points to. First, you consider the asteroid. It's a known killer. We have a conviction on its record for the extinction of the dinosaurs 66 million years ago. But a good detective doesn't rely on past behavior. You need specific evidence for this crime. The calling card of a major impact is a crater. For an event that caused the Great Dying, the crater would have to be enormous, hundreds of kilometers across. You've searched the globe, and no undisputed crater of the right age and size has ever been found. That's a significant missing piece. Another key piece of evidence from the dinosaur extinction was a thin, global layer of the element iridium, which is rare in Earth's crust, but abundant in asteroids. You scour the Permian-Triassic boundary for that same iridium signature. It isn't there. The evidence for an impact is circumstantial at best. The timeline also feels wrong. The geochemical clues suggest the extinction was a protracted, pulsing event, not a single knockout blow. The asteroid theory doesn't quite fit. You turn to your second suspect, the Inferno. You travel to modern-day Siberia and find yourself standing on a landscape of immense, rolling hills of dark volcanic rock. These are the Siberian Traps. This was not a single, cone-shaped volcano, but a whole province of the Earth's crust that tore open. For hundreds of thousands of years, colossal fissures bled lava onto the surface. The scale is almost impossible to visualize. Enough lava erupted to cover the entire United States in a layer a kilometer deep. Now, you compare this event to your evidence profile. Remember that massive carbon spike, the toxicology report from Section 3? The Siberian Traps provide a perfect explanation. As the magma surged upwards, it didn't just pour out. It cooked its way through one of the world's largest coal basins and vast deposits of carbonate rock, vaporizing them and injecting trillions of tons of carbon dioxide, methane, and sulfur dioxide directly into the atmosphere. This suspect not only had a weapon, but it also had the specific poison that matches the evidence. This colossal release of greenhouse gases would directly cause the runaway global warming, ocean anoxia, and acidification your forensic analysis uncovered. The timeline fits, the chemistry fits, the scale fits. The case against the Siberian Traps is becoming undeniable. The investigation is complete. The evidence has been weighed, the suspects interrogated. The asteroid theory, for all its destructive power, leaves no fingerprints at this particular crime scene. The verdict is clear. You can now definitively point to the true culprit, the Siberian Traps. This was not a swift execution from the heavens, but a slow, agonizing planetary poisoning from within. With the killer identified, you can finally reconstruct the crime, a chain reaction that brought a world to its knees. You stand on the plains of northern Pangea, 252 million years ago. The first tremor is not an earthquake, but a deep, sickening shudder of the crust itself. On the horizon, the sky does not darken with ash, but ignites. A fiery curtain, hundreds of kilometers long, tears open the earth, spewing fountains of incandescent lava into the sky. The air, thick with sulfur dioxide, quickly turns to acid, and the first rains to fall are corrosive, scalding the great Glossopteris forests and poisoning the rivers. This is only the beginning. For thousands of years, the eruptions continue, but the real weapon is invisible. Trillions of tons of carbon dioxide and methane pour into the atmosphere, wrapping the planet in a thermal blanket it cannot escape. The global temperature climbs relentlessly. 5, 8, then 10 degrees Celsius. The great inland deserts of Pangea expand, and the once lush polar forests wither and die. On the parched, dying plains, you see the Gorgonopsids. The invincible predators are now gaunt figures in a hostile landscape. Their prey, the herds of Dicynodonts, have starved. The very air is becoming unbreathable. The final act of this tragedy unfolds in the ocean. Warmed to the temperature of a hot bath, the sea can no longer hold oxygen. From the abyss upwards, the waters stagnate. This is the moment the dark, lifeless shale you held in your hand was formed. Purple sulfur bacteria bloom in the anoxic water, releasing clouds of toxic hydrogen sulfide gas that bubble to the surface, killing anything left in the shallows and potentially wafting over the land. The reign of the Gorgonopsids ends not with a roar, but with a choked gasp in a poisoned, overheated world. Their fortress had been breached, its foundations dissolved by chemistry. The great dying wiped the slate clean, leaving a profound silence. But into this silence, new life would eventually step. The extinction of the synapside dynasties left a power vacuum, clearing the ecological stage for a new group of survivors, the archosaurs, to evolve and radiate, eventually giving rise to the most famous dynasty of all, the dinosaurs. The case of the great dying is now closed. Standing here in the present, we look back across an almost unimaginable gulf of time, piecing together this story from chemical ghosts and silent layers of stone. It's a profound reminder that our planet is a living system, capable of both creating breathtaking worlds and, under the right and terrible circumstances, dismantling them with an efficiency that is nothing short of absolute. Through the patient work of geology and paleontology, we become the detectives for the planet, giving a voice to these lost empires and bearing witness to the greatest stories ever recorded in rock. The investigation doesn't just teach us about the past, it deepens our connection to the fragile, powerful, and ever-changing world we inhabit today.